This page will cover the first page of notes for the topic of log functions and their properties. The first thing that I want to emphasize is the relationship between exponentials and logs. So we have our base to some exponent that equals to some argument. We can rewrite that in terms of log by getting the base and saying the log of that base of the argument is equal to the exponent. So one easy way to remember is that you're going around in circles. It is the base to this exponent that will give you this argument. Let's go to example number 1 that asks us to rewrite our log problems in terms of exponents. So for example, if we have log of base 1/2 of 16 is equal to -4, remember this is our base. So we're going to have our base to this exponent. That's how we got that -4. It will equal to this argument. That's how we get our 16. And we can check that. That 1/2 to the -4th power means the negative exponent means I get the reciprocal. So that's going to be 2 to the 4th power. Notice my power is now positive because I got the reciprocal of 1/2, which is 2, and then I'm doing 2 to the 4th power, and that's how I'm getting 16. So let's do the same for part B. We're going to find our base, which is 5. We're going to give it to this exponent, and then we're going to get this argument. So that's how we're going to get 5 to the 1 power is equal to 5. Let's go to part C. Now what we're going to do is rewrite our exponential problem into logs. So we're going to first identify our base. That's this one right here. So we're going to say log to base 3/4 of our argument. That's our 1. That's why it came into here. Is equal to our exponent. So that's where our exponent is coming from. The easiest way to do this is to check by doing our little cycle here, going from the base to the exponent to the argument. So the base to the 0 power is going to equal to 1. And we know that anything to the 0 power is equal to 1. So this statement is true. If there's a 1 right here, then there's going to be a 0 over here. Let's look at the last problem, and I apologize that some of it got cut off here. But let's say we have 2 to the 10th power is equal to 1024. So we're going to write this in terms of logs. We're going to find our base. Our base is 2, so we're going to say log of base 2 of our exponent, which is 10, is going to equal to our argument of 1024. So one of the big things I want you to note is that an exponential function and logarithmic functions are inverses of each other, and that's the reason why we have this relationship. Let's take a look at the graphs for log functions. So one of the things I want to remind you of is that we can rewrite our log function in terms of exponentials. And then we can use this to find some of our points. What we do know is that the inverse looks like this, y is equal to 2 to the x. That's one of our parent functions, and we can see that these are some of the values that it will have. In fact, we can go back to our parent function page and write down this one for y is equal to 2 to the x power. So remember, what we're going to do is we found these by literally plugging them in. So 2 to the -2, remember the negative exponent makes it become reciprocal, and then I square it. I square the top, I square the bottom. That's how I get 1/4. That's where I'm getting this 1/4 from. Because they're switched positions for the log, I actually have to go to 1/4 and then down -2. That's where you see this red dot right here. We're going to do the same thing for -1. Remember, that just causes us to do a reciprocal. So the reciprocal of 2 is 1/2. Because I am doing the inverse of it, I'm going to go to 1/2 and -1. So I go to 1/2 and -1. That's this point here. We do the same thing for 0 and 1. So just to remind you, what we're doing is we're getting our 2 and we're putting it to the 0 power, and that's equal to 1. That's this point, but remember that is the graph that belongs to our exponential function. For our log function, we switch them around. So I'm going to go to 1 and then 0. So we can see our points there. So I'm doing the same thing for the rest of them. I'm plugging this to be a 1. 2 to the 1 power is 2. So that's where I get this point. I'm going to go over 2 and up 1. And we can see where we're getting those values. And I continue to do the same. That's where I'm finding these points. Notice that I can connect these into a smooth curve. And this is what our log function looks like. I always describe this function as like the side of my body with my arms sticking out. So I have my arm sticking out over here, and this goes all the way down the side of my body. Notice, just like the exponential function, that it does have an asymptote. In this case, it's going to have a vertical asymptote instead of a horizontal asymptote. So we'll always have a vertical asymptote of x is equal to 0, or the y-axis. Then we come over here and let's take a look at this other function of log, and this one has a base of 1/2. So again, we're doing the same thing where we're going to get 1/2 to the y value is equal to x, and then we can sit there and say, well, what if I had y is equal to 1/2 to the x power? This is the inverse of it. So I can sit there and make some points for this one. I'm going to put x here, my y values here. If x is equal to a -2, remember what we're doing. We're getting 1/2 and we're putting it to the -2 power. The negative causes a reciprocal, so it's going to be 2 and then a positive squared, and that's going to give me 4. So I'm going to take the inverse of this, so I'm going to go to 4, 1, 2, 3, 4, and down 2, and that's how I got this point. I'm doing the same thing if I plug in -1. 1/2 to the -1 power is the reciprocal, which is 2. So I'm going to go to the point 2 and down 1. And I'm doing the same thing here. Now, I don't want you to get all bogged down about it. I'm going to tell you a couple of things that you definitely need to know, but I'm just showing you how I'm coming up with this graph. And again, we put in 0. We know anything to the 0 power is 1. My reciprocal will be 1, 0. And then you can see all the other points as well. That would be 1/2. If I plug in 2, that would be 1/4. And we can see how these points are coming around. And again, we still have our asymptote to be the y-axis, as well as x is equal to 0. So we still have that. Well, let's talk about what these graphs do and what they contain. A couple of things that we should know is that it's always going to have a vertical asymptote of x is equal to 0. And they are continuous functions. We can also talk about the domain and range for these. The domain over here will be from 0 but not including 0 until we get to infinity, and the range will be from -infinity to infinity. And that's true for both of these functions. The other thing that we need to know are certain points. Just like we knew 0, 1 for exponential, we know 1, 0 for the log. Just like we knew 1, b, now we'll b, 1. And likewise, we also know that 1 over b, -1 is also a point. I'm getting these from the exponential graphs. So I really don't know how to graph log functions, but I do know how to graph exponential functions and then switch those points around because they are inverse functions of each other. And that concludes this video.